Dear learner, welcome to this video lecture on electrical cable joints and accessories. This is the lecture 17 of module 6 under the MOOCs course on electricity and electrical wiring. In the previous lecture, that is unit 16, we discussed the electrical wires and cables. In this unit, we will discuss about making various joints of electrical cables like twist joint, married joint, T-joint, etc. Various types of electrical wiring accessories, demonstration on glanding of cables, laying of cables, bending eyelets, stripping, crimping and connecting sockets, and stripping of wires and cables. After going through the video lecture, the learners will be able to demonstrate proficiency in electrical cable joints. They will be able to identify, construct and apply various electrical cable joints including twist joints, married joints and T-joints, ensuring secure and reliable connections. Then they will be able to identify and utilize electrical wiring accessories. They will be able to recognize different types of electrical wiring accessories and understand their functions, selection criteria and appropriate applications in electrical installations. Then they will also be able to execute cable handling and termination techniques. They will develop practical skills in stripping, glanding, bending, crimping and connecting electrical cables and sockets, following safe and industry standard procedures. Dear learner, at the outset, let us discuss the various electrical cable joints. Electrical cable joints are essential for connecting conductors safely and ensuring efficient current flow. In this video, we will demonstrate how to make different types of electrical joints, including the twist joint, married joint and T-joint. These joints are widely used in electrical wiring, repairs and installations. Let's begin by discussing the different types of joints one by one. Twist joint or Western Union joint. The twist joint, also called the Western Union joint, is one of the simplest and most commonly used methods for joining two conductors in line. It provides strong mechanical strength and good electrical conductivity. The steps for a twist joint are: strip about 1.5 centimeters of insulation from both ends of the wires. Cross the wires over each other to form an X shape. Twist each wire tightly around the other at least 5 to 6 times. Trim excess wire if necessary and wrap it securely with insulation tape. This joint is commonly used in low voltage applications and temporary wiring connections. Number 2, married joint. The married joint, which is used when two parallel wires need to be connected while ensuring a strong bond, is the next one. The steps involved for a married joint are: strip about 2 centimeters of insulation from both wires. Lay the stripped portions parallel to each other. Twist the strands of both wires together tightly. Insulate the connection using electrical tape. This joint is ideal for joining flexible cables and multi-stranded conductors. Number 3 is T-joint. A T-joint is used when connecting a branch wire perpendicularly to a main conductor. It is often used in distribution wiring and branch circuits. Steps involved for T-joint are: strip 2 centimeters of insulation from the branch wire and about 3 centimeters from the main conductor. Place the stripped section of the branch wire against the main wire. Wrap the branch wire tightly around the main wire 5 to 6 times. Solder the joint, which is recommended for permanent connections. Then cover the joint securely with insulation tape. This joint is useful for making electrical taps and branch circuits in household and industrial wiring. Apart from the joints we covered, here are some additional types of electrical cable joints, such as Britannia joint, which is used for overhead conductors providing strong mechanical support. Scarf joint is a soldered joint for heavy-duty applications. Rat tail joint, similar to a twist joint but used mainly for low power applications. Dear learner, let's now discuss some tips for safety in cable jointing operations. When making electrical joints, always remember these key safety tips. Ensure the power is turned off before working on any electrical connection. Use proper insulation materials to prevent short circuits. Solder joints where possible for enhanced durability. Avoid loose connections as they can lead to overheating and electrical hazards. Alright, now let's discuss about the accessories related to electrical wiring. The wiring accessories. In any electrical installation, wiring accessories play a crucial role in ensuring safety, functionality, and ease of use. These components connect, control, and protect electrical circuits in homes, offices, and industries. Switches are used to control the flow of electricity by making or breaking a circuit. There are several types of switches used in electrical wiring. Types of switches are single pole switch, which is used for controlling a light or device from one location. Two-way switch, which allows control of a device from two different locations, commonly used in staircases. Multi-way or intermediate switch, which is used in circuits where there are two or more switches control a single light. Push button switch, which is found in doorbells or control panels. A rocker switch, which is used in modern electrical fittings, replacing traditional toggle switches. Switches are essential in controlling electrical appliances and improving energy efficiency. Sockets and plugs provide the interface between electrical appliances and the power supply. Types of sockets are 2-pin socket, which is used for small electrical appliances without an earth connection. 3-pin socket, which includes an earthing pin for safety, commonly used in home appliances. Industrial sockets, which is designed for high power applications in factories and workshops. Proper socket selection ensures compatibility with electrical appliances and enhances safety. Lamp holders secure and connect light bulbs to electrical circuits. Types of lamp holders. Number 1, bayonet cap holder, which is common in household lighting fixtures. Number 2, screw type holder, which is found in LED and CFL lamps. Number 3, pendant holder, which is used for hanging ceiling lights. Number 4, angle holder, which is designed for wall-mounted lamps. choosing the right lamp holder ensures compatibility and proper illumination in different settings. Fuses and circuit breakers protect electrical circuits from overhead and short circuits. Types of fuses are: number 1, cartridge fuse, which is used in industrial and high power applications. Number 2, rewirable fuse, which is found in older domestic wiring systems. Number 3, miniature circuit breaker or MCB, which automatically trips when excessive current flows. Number 4, residual current circuit breaker or RCCB, which protects against electric shocks by detecting leakage currents. These accessories are crucial for electrical safety, preventing fire hazards and equipment damage due to overloading conditions. Conduits and cable management accessories protect and organize electrical wiring. Types of conduits are: PVC conduits, which are lightweight, corrosion resistant, and commonly used in domestic wiring. Metal conduits, which provide high durability and protection against mechanical damage. Flexible conduits, which are used in areas requiring bendable wiring solutions. Dear learner, some additional cable management accessories used commonly are: cable clips and ties, which help in organizing wires neatly. Junction boxes, which protect wiring connections and ensure safety. Good cable management prevents wire damage and enhances the longevity of electrical systems. Some additional accessories improve convenience and efficiency in electrical installations, such as dimmers, which adjust light brightness for energy efficiency. Fan regulators, which control fan speed in homes and offices. Timers and smart switches, which automate electrical devices for energy savings. Modern accessories enhance control, automation, and energy efficiency in electrical systems. To summarize this part of the lecture, we explored various types of electrical wiring accessories, including switches, sockets, lamp holders, fuses, conduits, and smart devices. When working with electrical installations, always follow these safety tips. Ensure all accessories meet standard quality and safety regulations. Use proper insulation and protection to prevent electrical hazards. Hire a certified electrician for complex installations. Dear learner, after discussing the cable joints and accessories, let us now attempt some multiple choice questions to test our understanding. Next, we will discuss the cable termination methods used commonly for all electrical circuits. Proper cable termination is crucial for ensuring a safe and reliable electrical connection. In this section, we will demonstrate essential techniques including cable glanding, laying, bending eyelets, stripping, crimping, and connecting sockets. These steps are commonly used in electrical installations industrial wiring and maintenance work. First, let's look at cable glanding, which secures cables to panels, enclosures, or electrical boxes while providing strain relief and earthing. Steps for cable glanding are: number 1, select the appropriate gland size based on the cable diameter. Number 2, strip the outer sheet of the armored cable using a cable stripper. Number 3, fit the gland nut and washer into the cable. Number 4, expose the armor wires and spread them evenly. Number 5, insert the gland body and tighten it with a spanner to secure the armor. Number 6, attach the lock nut and earth tag for proper grounding. A well-installed gland ensures mechanical support and prevents cable damage in electrical panels and distribution boards. Now let's move on to cable laying, which involves arranging cables safely for electrical distribution. The 3 main methods are: number 1, surface laying, which is used for securing cables with clips or conduits along walls or ceilings. Number 2, underground laying, used for burying cables in trenches with sand cushioning and protective covers. Number 3, tray and duct laying, which is used for cable trays or ducts for organized routing in industrial setups. Proper laying techniques prevent cable strain, reduce electromagnetic interference, and improve system reliability. Next is the eyelet bending, which is useful for connecting wires to screw terminals and bus bars. Steps for bending eyelets are: number 1, strip about 1.5 centimeters of insulation from the wire end. Number 2, use pliers to bend the exposed conductor into a neat loop called eyelet. Number 3, ensure a loop fits securely around the terminal screw. Number 4, tighten the screw to hold the eyelet in place. This method ensures a firm and conductive connection, especially in control panels and switchboards. Next, let's discuss wire stripping and crimping, essential for preparing wires before termination. Wire stripping steps are: number 1, choose a wire stripper suitable for the wire gauge. Number 2, insert the wire into the correct notch of the stripper. Number 3, squeeze and pull to remove the insulation without damaging the conductor. Please avoid cutting conductor strands while stripping, as this weakens the wire's conductivity. Next important point to mention is crimping of lugs of wires. Proper crimping practice steps are: number 1, select the correct terminal lug based on wire size. Number 2, insert the stripped wire into the lug or ferrule. Number 3, use a crimping tool to press firmly until a secure connection is formed. Proper crimping ensures low resistance connections and prevents overheating in electrical joints. Finally, let's look at connecting a socket, a crucial step in installing power outlets. Steps for socket connection. Number 1, identify the terminals. L for live or phase, which is usually a brown or a red wire. N for neutral, which is usually a blue or a black wire. E for earth, which is usually a green or a yellow wire. Number 2, insert the wires into their respective terminals. Number 3, tighten the screws securely to ensure good electrical contact. Number 4, fix the socket cover and test with a multimeter for proper connectivity. A correctly wired socket ensures safe and stable power distribution in homes and workplaces. To summarize, we covered essential cable termination techniques such as cable glanding for secure cable entry, cable laying for safe routing, eyelet bending for firm screw connections, stripping and crimping for strong terminations, socket connection for power distribution. When working with electrical cables, always follow these safety tips. Use insulated tools to prevent electric shocks. Double check wire connections before energizing the circuit. Follow standard wiring color codes for correct polarity. Stripping wires and cables is a fundamental skill in electrical work, ensuring proper connections and safe installations. Using the right tools and techniques helps prevent damage to the conductor, ensuring reliable electrical performance. Before we begin stripping, let's understand the common types of electrical wires and cables. Single core wire, which is used for small electrical connections typically found in household wiring. Multi-stranded wire, which is flexible and commonly used in appliances and industrial wiring. Coaxial cable, which is used for data transmission, including TV and internet connections. Armored cable, which is found in outdoor and industrial installations, providing extra protection. Each type requires a specific stripping technique to avoid damaging the inner conductor. The right tool ensures precision and safety when stripping wires. Common stripping tools include manual wire strippers, which is the best for single core and multi-stranded wires. Automatic wire strippers, which ensures quick and precise stripping without damaging conductors. Cable sheath strippers, which is used for stripping outer insulation from thick cables. Utility knife or cutter blade, which is used for stripping large cables when a stripper is not available. Now let's demonstrate how to strip different types of wires safely and efficiently. Stripping a single core wire. Choose the correct notch on the manual wire stripper based on the wire gauge. Insert the wire, squeeze the handles and gently pull off the insulation. Inspect the exposed conductor to ensure no strands are cut. This method is used in household wiring and electrical panel connections. Next one is about stripping a multi-stranded wire. Use wire strippers to ensure a clean cut without damaging strands. Place the wire inside the tool and press the handles. The insulation is removed automatically. Twist the exposed strands together for a neater connection. Multi-stranded wires require careful stripping to prevent conductor breakage, which can weaken the connection. Next, we will see the stripping of a coaxial cable. Use a coaxial cable stripper to remove the outer insulation. Peel back the metallic shield and remove the inner insulation to expose the conductor. Ensure the shielding remains intact for proper signal transmission. Coaxial cables require precision stripping to to avoid signal loss and maintain transmission quality. Stripping armored cable and sheath removal. Use a cable sheath stripper or a utility knife to score the outer sheath carefully. Bend the cable slightly along the cut line to break the insulation. Peel off the sheath and trim any excess armor or insulation. Armored cables are commonly used in high power applications, and stripping them requires extra care to avoid damaging the inner wires. Safety is critical when stripping wires. Follow these best practices. Always turn off the power before working on any electrical wiring. Use the right tool for the specific wire type and gauge. Avoid cutting too deep, as this can damage the conductor. Hold the wire firmly to ensure a clean strip. Check the stripped wire to confirm there are no cuts or breaks in the conductor. Dear learner, please note that a poorly stripped wire can lead to weak connections, increased resistance, overheating, and even electrical failures. Always aim for a clean, precise strip. In this section of the lecture, we covered different types of wires and cables, essential stripping tools, step-by-step stripping techniques, safety precautions to follow. Proper wire stripping ensures strong electrical connections, reduces risks, and improves efficiency in electrical work. Dear learner, let us now attempt some multiple choice questions to test our understanding of this last part of the lecture. So dear learner, this video lecture provides a practical overview of essential electrical wiring techniques. It begins with demonstrations of various cable joints, including twist joints, marriage joints, and T-joints, explaining their applications and best practices. The session then covers different types of electrical wiring accessories, highlighting their functions and correct usage. Additionally, the video includes hands-on demonstrations of cable handling techniques such as glanding, laying, bending eyelets, stripping, crimping, and connecting sockets. By the end of the lecture, viewers will have a clear understanding of fundamental wiring skills and safe electrical installation procedures. Dear learner, at the end of the video lecture, let us now check our understanding by attempting the following questions. For further reading, you may refer to the following reference materials. Thus, we come to the end of the video lecture. The next lecture will be on the use of protective devices and safety regulations. Thank you.